In this video, we will learn about the characteristics of a sound. So, loudness of the sound. So, it is a characteristic due to which we are able to distinguish between a loud, that is intense sound, and a soft, that is weak sound, in spite of the fact that both the sound have same pitch and quality. Now, we take a tuning fork and we gently strike its prong with a rubber pad so that it starts vibrating. Now, you will hear a feeble, that is soft sound. Now we again strike the same tuning force with a rubber pad, but this time we strike it harder. Now we listen a loud sound. Thus, for the same tuning fork, we can change the loudness of the sound produced by increasing the amplitude of vibration of its prong. Again, while listening to the program on a radio set, if you suddenly increase the volume of a radio set, the loudness of the sound increases for the same program. Now, on increasing the volume of the radio set, you are imparting more energy in the vibrating system and the loudness increases because the system is now vibrating much harder and much faster than the previous time. Now, loudness is a subjective quantity and it depends on the sensitivity of our ears of the listener. The objective quantity corresponding to loudness is the intensity of sound. Basically, loudness of a sound depends on its amplitude. Okay, higher is the amplitude of a vibrating object, louder is the sound, which means that loudness is directly proportional to amplitude. Now, as an example, if one beats the membrane of a drum with a drumstick gently, then the sound produces soft and with a lesser amplitude, or we can say energy, as you can see in the first figure. But if I beat the membrane drum harder or at a harder pace, the sound is produced is louder on the account of greater amplitude, as you can see in this particular picture. The amplitude has increased. This is the amplitude, this has increased from this particular case. Okay. Now, a sound wave spread out from its source in all directions. Okay. So if this is a source, the sound wave will be spread in all these particular directions as it moves away from the source. So its amplitude and its loudness will decrease as the distance from the source will increase. Now, a louder sound can travel a larger distance as it is associated with a higher energy. As an example, during Diwali, you might have listened that the sound produced due to explosion of a high power cracker bomb, we can listen to the sound of it from a quite a large distance. Second is the intensity of sound. So intensity of a sound is given by the amount of sound energy per unit time per unit area. So this is the formula of intensity. Now E here is the sound energy. A is the surface area and T is the time. So this is the formula for intensity. Now intensity is objective quantity which can be easily be measured. Now a normal ear can perceive sound whose intensity is even 10 to the power minus 12 watt per meter square, okay, which can corresponds to zero level of loudness. Now the SI unit of intensity of sound is, now the unit of energy per unit area per unit time is joule per meter square per second, okay, or I can say watt, which is joule per second divided by meter square, okay. Now factors affecting the intensity. So first of all, the amplitude of vibration. So the intensity of the sound produced by a vibrating object is directly proportional to the square of the amplitude of its vibration. Now, if A is the amplitude of vibration, then intensity is given by this relation. Or if a constant is applied, I can say I is equal to Ka square. Okay, where K is a constant of proportionality. Second is the distance of a place from the sound source. So the intensity of sound at a given place is inversely proportional to the square of the distance from that given place. Okay, from the source of the sound. As one goes farther from the source, the intensity of sound heard becomes less intense. Okay. Now, surface area of the vibrating object. Now, if the surface area of the vibrating object is more, like this, then it will provide more energy and hence the intensity will be more. So, if the surface area is more, the intensity will be more. Now, it is due to this reason that the sound produced by a big sized drum is louder than the sound produced by a small drummet. Now, the density of the medium. So, if the density D of a medium present between the source sound and the listener is higher, then the intensity will be more at that particular time, because now the sound vibrations have much more molecules to interact with during its commission. Presence of resonant objects. Now, if some resonant objects are present near the vibrating object, then due to resonance, we know that the amplitude and the intensity will increase. Okay, intensity and loudness. So, loudness is a subjective quantity which depends on the intensity of the sound and the sensitivity of the ear of the listener. Now, in other words, loudness is a measure of the response of the listener's ear to the sound intensity. Now, for a normal ear, the loudness L and the intensity are correlated as K log base 10I. Okay, so this is a relation. You just remember this relation, and the logarithm you will learn in your mathematical classes. K is the proportionality constant over here. Now, its value in SI system is 1. Okay, now the loudness SI unit is bell. Okay, now, if intensity of a given sound I be watt per meter square, then the corresponding level of loudness in bell would be log base 10 I upon I naught. Okay. Usually the loudness is measured in decibels, and we know that 1 decibel is equal to 1 upon 10 bell. So if I want to calculate the loudness in decibel, then it would be 10 log base 10 I upon I naught. Okay. Thus, we can say the intensity level 10 raised to the power minus 6 watt per meter square means that the loudness of 60 decibel and intensity of 1 watt per meter square means a loudness of 120 decibels. Okay, I hope this topic is clear to you. Thank you.